This is a demonstration of what it's like to multiply fractions. First I'm going to start by multiplying whole numbers because you should be very familiar with that. Remember, multiplication is just repeated addition. So 4 times 3 is the same as saying you want 4 sets of 3. Or, so you have 4 sets of 3. Or you want 3 sets of 4. So in that case, this would be 3 sets of 4. Well, fraction multiplication works exactly the same. This can be read as 4 sets of 2/3 or 2/3 set of 4. Okay, either way, whichever way makes it easier. 4 sets of 2/3 is going to look like this. You're going to have 4 sets of 2/3. So what does 2/3 look like? Well, it looks like this. Okay, there's thirds. There's 1 set of 2/3. Here's another set of 2/3. Here's another set of 2/3. And here's another set of 2/3. And then remember, your answer for multiplication is out of the whole. So the question is, how many thirds do you have? So we have 2, 4, 6, 8 thirds, which is going to be 1, 2, 3, 4, 5, 6. So there's 2 wholes, which, again, if you divide by 8 by 3, there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 2 and 2/3 total. Okay, so that's what you get when you multiply 4 by 2/3. You can also do 2/3 of 4, which looks the world, but it makes sense. It's going to look just like this. So you're looking for 2/3 of 4. Well, the first thing you do is you draw 4. Okay? Now, if you want 2/3 of 4, the easiest way to do that would be to go ahead and divide each of these pieces into thirds. So here's 4 pieces. 2/3 of each of them is going to be 2/3 of, there's 2/3 of 1. There's 2/3 of 2, 2/3 of 3, 2/3 of 4. So you have 2/3 of 4, which is going to give you, again, the same thing, 8/3. So this is going to be exactly the same thing. Okay, it's going to be equal. So that's what you get when you multiply fractions, and this is when you're multiplying a whole number by a fraction. What I'll do next is do a fraction by a fraction. Okay, so this is an example of 2 fractions being multiplied. Let's say we have 1 1/4 times 1/5. Well, this is the same. Remember back to our example, if we had 3 times 4, we have 3 sets of 4. 1 1/4 times 1/5 is saying that you want to multiply 1/5 of 1 well, you're going to find 1/5 of 1 1/4, or you can find 1 1/4 of 1/5. You can do it either way because multiplication is commutative. Whichever way makes more sense. So this is either 1/5 times 1 1/4. In other words, you have 1 1/4 groups of 1/5, or you have 1/5. You have 1/5 groups of 1 1/4, which is a little harder to see. It's probably easier to take the whole number, the bigger number, and make this many of the 1/5. So you want 1 1/4 groups of 1/5. So the question is, what does 1/5 look like? Well, this is what it looks like. 1, 2, 3, 4, 5. Here's fifths. And I'm only going to draw 2, and I'll explain to you why. Is because, oh, this is going to be a little tiny, but that's all right. Actually, I need to make those bigger because we're going to end up, I need to make one of those quadrants. Let's do this because I'm going to need more room, and I'll show you why in just a minute. So 1, 2, these are all supposed to be the same size, so just pretend like I drew these equal, even though they're not. Okay, so what does 1/5 look like? Well, 1/5 is this part right here. There's 1/5 and there's 1/5. Now this says I want 1 1/4 of 1/5. So I want 1 whole set of 1/5, and I want 1/4 of a set of 1/5. That's what we're looking at. So we're taking this many of 1/5. Well, here's a whole set of 1/5. So this is the starting point that I'm going to have. So I have a whole set of 1/5, but then there's my 1. So this is the 1. But then I just want 1/4 of 1/5. So how much is 1/4 of 1/5? Well, hopefully by now you guys are clear on the fact that you need to divide this up into pieces so you can see what 1/4 looks like. Well, on your whole thing, this is 1/4. All right? That's what fourths look like. So 1/4 of 1/5 is going to be this much right here. Okay? Because that's 1/4 of 1/5. If you take the 1/5 and you divide it into 4 pieces, that's what it looks like. I extended these down because remember your answer for multiplication is out of the whole. So I need to know what this looks like in the whole, which is this whole block, how much this is. This is 1/4 of just the 5, but how much is it of the whole? Well, this is 1 out of 4, 8, 12, 16, 20. So, because 4 times 5 is 20. So this is 1 out of 20. Okay, and over here this is 1, which is just 1/5. So when you add these two together, you're going to get your total. So 1/5 and 1/20, this is where you go back to addition of fractions. If you have a 5th into 20ths, this is equivalent, if I divide this into 4 pieces so that they match these sizes, this is the equivalent of 4 20ths, all right? So I'm adding 4 20ths to 1 20th, which gives me 5 20ths, which is the same as 1/4, all right? Now we can check our answer by actually multiplying. If you remember how to multiply fractions, we'll go ahead and do it the old-fashioned way with the algorithm where you turn this into an improper fraction. 4 times 1 plus 1 is 5/4 times 1/5. If you multiply this together, you get 5/20, which is exact. Remember, when you multiply fractions, the algorithm is you multiply the top together and the bottom together, and sure enough, there's 5/20ths, which is exactly what I got here. Okay, I didn't write it down here, I wrote it up here, but that's your answer, which is equal to 1/4. So once again, let me walk through this just so you can be clear on it. I wanted 1 1/4 of 1/5. So I took 1 of 1/5. Here's 1/5 right here. Okay? You can just ignore those black lines. I just did that so I could add like fractions. So there's my 1/5. And then I needed to take 1/4 of 1/5. Well, I took the 1/5 and cut it into 4 pieces. So to start with, I was only looking at that in 4 pieces, so it was just one of these. But then I needed to extend the line so I could see how much one of these was out of the whole. Because multiplication, the answer is always out of the whole. Okay, so that's what you get with that. And I'll do another example of a different type. Okay, in this example, and you'll notice in the last example, when you took you took 1/5 times 1 1/4, you ended up with a number smaller than 1 because you're taking a very small part, 1/5 of a number. This is bigger than 1, but it's not much bigger than 1, and when you take 1/5 of it, your answer is going to be less than 1. So you need to think about, logically, is my answer going to be bigger or smaller, and what am I looking at? So make sure you use do some deductive reasoning while you're doing this and think about what you have. So 2/3 times 3/4 can be written in 2 ways. It can be written as 2/3 of 3/4 or 3/4 of 2/3. Okay, so I'm going to go ahead and go like this to separate these two. All right. So this is going to be the 2/3 of 3/4 example. So I'm taking 2/3 of 3/4. So I'm going to start by drawing the 3/4, which we'll draw like this. You could draw your lines in any way you want. I usually start horizontally and then cut them up vertically if I need more. So there's my fourths. Remember, I'm taking 2/3 of 3/4. And 3/4 is going to be 1, 2, 3. Okay, now when you're looking at multiplication of fraction, you're taking 2/3 of 3/4. You're just taking 2/3 of the shaded area. So for now, we're going to pretend like this doesn't even exist. You want 2/3 of that area right there, okay? Which is going to be, hopefully you can see, that's going to be, and I usually encourage people to box this instead of shading it so you don't get confused. That's 2/3 of these 1, 2, 3, there's 2, all right? Then you can go ahead and add on your bottom piece. This was actually supposed to be 3/4, so there was a 4th piece here. The reason you need to do that is you need to figure out how much you have out of the total. The total were 4 4s. So now you look at what you boxed out of everything that was in the whole. Well, you have 2 out of 4, or half. So the answer to this would be 2 out of 4, or 1 out of 2. You can think of it as a half, okay? So the answer is going to be 1/2. So if you take, again, repeat this, if you take 2/3 of 3/4, you get a half. Again, multiplying by the algorithm, multiply 2 across, you get 6, 4 across, you get 12, so 6 over 12 gives you 1/2. So you get the same answer with the algorithm, okay? So that's what that looks like. Now let's go ahead and do 3/4 of 2/3. Well, let's draw 2/3. There's 2/3. Oh, there's thirds. I need to shade it in to actually get 2. All right, there's 2. Now, I want 3/4 of that. Well, the problem we have right now is that I don't have fourths. I have thirds, I have halves. So I'm going to cut just the shaded area instead of the whole thing. I'll just cut the shaded area into fourths just to make sure you guys are clear, and then you extend that. So I only have 2 right now, so I can't talk about fourths out of this until I make 4. So if I do this, now I have 1, 2, 3, 4 of the shaded area. So if I want 3 out of those 4, then the amount that I want is going to be this. Okay, so there's how much I want. That's 3/4 of the 2/3. And then what you need to do is you need to extend your line down so all the portions are the same. So everything's in terms of the same size. So the question is, what size are those? Your hole, this is your hole. How much are each of these blocks? Well, if you count them, there's 6. So each of these is a 1/6. And I have boxed or circled 1, 2, 3, 6, which is 1/2, which had better be the same answer. Whoops, that's good, because that's exactly what I got over here, so it should be the same. Okay, so when you're multiplying fractions that are smaller than 1, you're going to be taking part of a part. Okay, so you're going to, whereas before we were taking, well, we were taking part of a whole. So there's multiple ways to think about this. Okay, so let me do another one. I'm going to do another one now with multiplying mixed numbers where you've got 2 numbers that are bigger than a whole, just for some more practice. So now you have 3 2/3 times 1 3/4, which can be seen as 1 3/4 of 3 2/3. Okay, or 3 2/3 of 1. We'll do that next. Okay, so 1 3/4 of 3 2/3, well, it's one full set of 3 2/3, which looks like this: 1, 2, 3, and then there's your thirds. And we have a whole set of 3, 1, 2, 3, 1, 2. Okay, so that's the set of 1. Right here is the set of 1. Okay, so there's your whole set. And then you're going to have 3/4. So this is one whole set, and then you're going to add that to 3/4 of a set of this. So you're going to add that to 3/4. So again, you have 1, 2, 3. Hopefully this won't leave the picture on the camera. So there's, again, there's 3 3/4. Oops, wait, 3 2/3. So 1, 2, 3 2/3. Okay, so there's your 3 2/3. And you're going to go ahead and just take 3/4 of that. You don't want the whole thing. It's not going to be 1. It's just going to be 3/4. So we have to figure out how much 3/4 is. Well, there's not a full set of 4 of the whole, so I can't just take 3 of them. So I'm going to have to divide everything into 4. So here's 1, 2, 3, 4. 1, 2. Oops, I didn't mean to use that color. Let me use the black marker. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3. And then this one I'm going to have to cut like this to get force out of it. So hopefully that's readable. I just cut it 4 ways that way. Now I'm going to box 3/4 of each of these. So here's 3/4 of this one. Here's 3/4 of this one. Here's 3/4 of this one. I have 1, 2, 3, 4, 5, 6, 7, 8. 3/4 of this one is going to be this. Now remember, you're only taking the shaded area, 3/4 of the shaded area, which is these 2 squares, this square on this square. So that's not drawn real great. Let me draw this a little better. So there you go. So this is, and this whole thing is shaded. So I need to figure out how much I have just grabbed. So let's go ahead and add this. Out of this hole, I took 3/4. Out of this hole, I took 3/4. Out of this hole, I took 3/4. I boxed 1, 2, 3, 4, 5, 6 of these, and out of all of these are 12s. Okay? So what I have is I have one whole set of 3 2/3, and I've added it to a set of 3/4 plus 3/4 plus 3/4 plus 6, 12, which is 3/4 of 3 2/3. So the $1,000,000 question is, how much is that? So let me go ahead and add that together. So we have 3 2/3 plus 3/4 plus 3/4 plus 3/4 is 9/4. Remember, when you add, the 4 just tells you the piece sizes. You're adding just the shaded area. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you're adding 6/12. Okay? The whole part is just going to be 3 so far. I can't add these because they're not alike, the piece sizes are, and I have thirds, fourths, and 12ths. So I'm going to turn this into 12s. If I turn this into 12s, I have to multiply by 3, so that means I have to multiply 9 by 3, which is 27. So I have 27 12ths. If I turn the 3 into 12ths, I had to multiply by 4, so this gets multiplied by 4 as well. So I have 3 and 8 12ths plus 27 12ths plus 6 12ths. Well, 27 and 8 is 37 minus 2, which is 35, plus another 6 is going to be 41 12ths. So I have 3 and 41, oops, let me do that in black so you can see it. 3 and 41 over 12 is my total, okay? Which is not actually simplified, because if you look, 41 is much bigger than 12, so I can pull some more 12ths out of that. I can pull the 12 12ths out of that. Let's see, 12 goes into, 12 times 3 is 36, so I can get 3 more out of that. So I can get 3, I can pull 3 whole 12s, 12 12ths out of 41, which is 36, which leaves me with 5 12ths. So my final answer is going to be 9 and 5 12ths. Okay, which is what I get. Now this is using multiple concepts. It's using the addition property of equations. It's using the equivalence property, the idea that you have to make the fractions equivalent before you can add them. They have to be the same size pieces. And it's using the multiplication property. So these all things all kind of fit together. So you need to know what you're doing because they build on each other, okay? Now remember that. I'm going to put this up here, 9 and 5 12ths, just so I remember that was the answer, so I can compare it to what the answer would be if I used the algorithm. So let's go ahead and do the algorithm and see if we agree that using the arithmetic process that you guys were probably all taught in school, it actually gives us the same answer. So let's see. That's where you have 3 and 2/3. So 3 out of thirds is going to be 3/3 and 3/3 and 3/3, which is 9/3. And then 2 more is 11/3. This is where you did the old multiply the 3 times the 3 and add the 2. I don't know if you guys remember that, but that's what you were doing. Is you were seeing how many sets of 3/3 was in there. And then you multiply that by 4 times 1 is 1 set of 4, and then 3 more is 7 fourths. And you get 77 over 12. Did I add that right? 3, oh, you know what I did? I just realized I said 3 and 3 is 9. I multiplied. I was actually supposed to be adding those 3's. If you were thinking that and I confused you, I apologize. That should be a 6. I'm pretty sure that's what we have. Yeah, that's supposed to be a 6. Because if you remember, just so I don't confuse you, I had 3 plus 3 plus 5 12ths. And I said that was 9. That's not 9. That would be 6. So just ignore that. Sorry about that. If you were lost, I apologize. I just realized that I did that. So anyway, what I have here is 77 12ths. 12 times 6 is equal to 72, because 12 times 5 is half of 12, which is 60, and 12 more is 72. So 72, so that means I can get 6 12ths out of here. The difference between 72 and 77 is 5. So sure enough, I got the same answer when I used the algorithm. So we know we did our distribution. So you can check your answers when you draw these things by doing the algorithm.